Hello, everyone. Welcome to um, math. This is lecture number 18, and it's going to be on angles. We're going to start our section, chapter 7, on trigonometry. So this is lecture 18. Okay, so let me start by defining an angle, and you're probably familiar with a lot of this stuff, but I think it's good to review it. So if we have these two rays, right, where we have an initial side and then we have the terminal side, the point where the rays meet is called the vertex. And then the angle is always measured, at least if you're going to represent a positive angle, it's measured counterclockwise. So it's measured from the initial side to the terminal side counterclockwise, like in that direction. So let me write that here. So positive angle is measured counterclockwise. Okay, now some common angles. I'll just do some of the angles that where the terminal side lies right on one of the axes. Let's say, here, I'll start with the example. Let's say the initial side and the terminal side are both right on the x-axis, so that's the initial side and the terminal side. So obviously in this case, this would represent 0 degrees, right? There's no angle between them. If the initial side is along the positive x, so like this in blue, and then the terminal side is, say, along the positive y, then that angle is going to be positive 90 degrees. Okay, if I have the initial side along the positive x and the terminal side is along the negative x, then that angle from here to here would be 180 degrees, like halfway around. And then if I have the initial angle on the positive x the initial side in positive x, and then the terminal side on the negative y, then this angle from there to there is 270 degrees. And of course, if you go all the way around, so now if the initial angle is positive x, but I go the initial side, I keep calling the angle initial side, and I go all the way around, and let's say the terminal side also lies around right on the positive x-axis, then that's going to be 360 degrees. Okay, what happens if you measure clockwise, right? So remember, we're measuring counterclockwise. Well, if you measure clockwise, then the angle is negative, right? So that's the difference. So, for example, if I have let's say the initial side again is along the positive x, and I want to measure, let's say the terminal side is halfway between, like in the second quadrant. So if I measure counterclockwise, this would be a positive 135 degrees. If I measured clockwise from here to here, this would be a negative 225 degrees, right? And they represent the same angle. It's just in one case you decide to measure it counterclockwise, which is positive. The other case we decided to measure it clockwise, which would have a negative angle. All right, now I've been using degrees so far, but another way that we can measure angles, another unit, is something called radians. So we need to talk about that. And then we also want to be able to convert between degrees and radians and vice versa. Okay, so, all right, converting between degrees and radians. All right, so again, we know that a full rotation right? If I have, let's say I have a circle here. So it looks like that. So we know that a full rotation is 360 degrees, right? If I measure all the way around and say my terminal side is right with the initial side, then this is 360 degrees. So 360 degrees is a full rotation. Right, if you turn around once. Well, what is that in radians? Like, what does it mean? First of all, what does it mean to measure an angle in radians? Let me first give you the definition of that. So if I have, let me draw a circle again. So it turns out radians is basically a ratio. It's a ratio, let me clean this up a little bit. It's a ratio of what's called the arc length. So in this case, the arc length is from here to here. And usually that's called S. And then the radius is this length right here. So we usually call that R, right? That'd be like the radius of the circle. And then let's say the angle is this angle right here. So this is theta. So in radians, this angle is defined to be the ratio of the arc length to the radius. Okay, actually, let me do that in the correct colors. So it's a ratio of the arc length, S, to the radius. All right, so this, again, this S here is the arc length. So it's the length of that curve, right? It could be in any units you want, in meters, centimeters, whatever it is, inches. And then the R is the radius. So this R here is the radius. Remember, that's the distance from the center of the circle to the edge, right, of the circle. And then the green here is the angle in radians. Okay, and again, it's defined to be the arc length divided by the radius. So notice here that whatever you measure the arc length in and the radius in, those units are going to cancel. So the units are actually unitless, like there are no units for radians, but we usually call it radians just to remind ourselves that we are measuring the angle as that ratio. Okay, so people will also use like rads and stuff just to remind yourself that you're measuring the angle based on that ratio, that it's radians. But in reality, there are no units there. Okay, if we wanted to, we could rearrange that formula. So sometimes people want to calculate the arc length. So if you wanted to find the arc length, that would simply be the radius times the angle, but the angle has to be in radians, right? So you can just rearrange that formula if you need to. All right, what about converting between degrees and radians? So if once around, we know once around in degrees is 360 degrees, right? So if I draw a circle here, and again, I go once around, in terms of degrees, that's 360 degrees. What is it in radians? Well, let's figure this out. So here's my circle. So remember, in radians, that angle, right, in radians, is going to be the arc length. But what is the arc length is like the total distance around the circle, right? It's this total distance all the way around. Well, we know what that is, right? It's the circumference. In this case, the S is just the circumference of the circle, right? It's the entire thing if there's one resolution. So I'll say if one revolution, then the S is simply going to be the circumference. And we know how to find the circumference of a circle. Remember, that's equal to 2 pi r. So in this case, S is 2 pi r. So that means the the angle in radians is going to be, remember, it's S over r. So it'll be the total distance around, which is 2 pi r, divided by r. And look, the r's cancel. So it turns out it's equal to 2 pi radians. Once around is 2 pi radians. Okay, and we usually just use RAD to represent radians. So this tells us that 360 degrees is equivalent to 2 pi radians. Now what you can do is you could divide both sides by 2, and usually this is the way you see this conversion factor. You see that it's 180 degrees, so I'm dividing both sides by 2, is equal to pi radians. Okay, so that's what we want to use when we convert between degrees and radians and vice versa, radians to degrees. Okay, so how do we use that conversion factor? Well, think of it, right? If I divide both sides by 180 degrees, I can write this as pi radians over 180 degrees. Or if I go the other way, right, divide by pi, I can write this as 180 degrees divided by pi radians. In both cases, these are in essence equal to 1, right, because they represent the same angular displacement, right? They're both represent like halfway around. So these are what's called unit conversion factors. Unit conversion factors. And which one do you use? Well, that depends on the problem. Depends on whether you're converting degrees to radians or radians to degrees. So for example, right, let's say I want to convert 45 degrees to radians. Okay, so I start with 45 degrees. I want to get my final answer in radians. Well, to do this conversion, I need to multiply by one of those conversion factors. Well, if you think about it, right, we want radians, the units of radians, to survive in the answer, and we want degrees to cancel. So which conversion factor do I use? Do I use pi radians over 180 degrees, or do I use 180 degrees over pi radians? Well, if you think about this, right, if I multiply by pi radians over 180 degrees, then the degrees will cancel, those units will cancel, and I'll end up with radians, and that's what I want. Okay? So in this case, this would be, I'll do the work below it. This will be 45 pi over 180. But then you can simplify that, right? It turns out 45 goes into 45 once. So this goes into once. It goes into 180 4 times. So this is the same as pi over 4 radians. So 45 degrees is pi over 4 radians. All right, here's another one. Let's say we want to convert 210 degrees to radians. Okay, so I start with 210. I need to multiply by pi over 180, so pi radians over 180 degrees. Notice that degrees will cancel. And let's see, it looks like 30, right, goes into both of these. So 30 will go into 210 7 times, and 30 will go into 180, I guess, 6 times. So this is going to be 7 pi over 6, or 6 pi radians. And that would be the answer. And of course, to go the other way, you simply use the other conversion factor, right? So if I start with, let's say I want to convert pi over 6 radians to degrees. So now I start with pi over 6 radians. I want to end up with degrees. I want radians to cancel, so now I have to use the unit conversion factor in the other form, right? Now I want to multiply by 180 degrees over pi radians. And notice here what's going to happen. Pi's are going to cancel, the units of radians will cancel, and then I can simplify this, right? 6 goes into 6 once, 6 goes into 180 30 times, so this is simply going to be 30 degrees. Okay, so we go back and forth converting just by using those unit conversion factors. Either multiply by 180 degrees over pi radians or pi radians over 180 degrees, depending on which way you're going. Okay, now there are some common angles that you should just know. Let me bring up a picture here. Okay, so these are common angles in both degrees and radians that you should be familiar with, right? So again, if you go directly to the right, in a positive x-axis, that's going to be 0 degrees, or if you go all the way around, it's also 360 degrees. In terms of radians, it'll be 0 radians, right, if you're at 0 degrees, or if you go all the way around, the angle in terms of radians would be 2 pi, right, because remember, once around is 2 pi radians, right, so 360 degrees is equal to 2 pi radians. Then if I go, basically there's increments of 30 degrees here, right? So if I do an increment of 30 degrees, well, if you convert 30 degrees into radians, you're going to find that that's pi over 6, right? 1/6 pi radians, so pi over 6 radians. So each of these increments is 30 degrees, or in terms of radians, it's pi over 6 radians. So if I go 2 of these increments, right, now I'm going to 60 degrees, because 2 times 30 is 60, or 2/6 pi, which I can simplify to pi over 3. So 60 degrees is the same as pi over 3 radians. If I go 3 of these, right, so that's 3 times 30, which is 90 degrees. We already know that straight up is 90 degrees. Well, that's the same thing as 3/6 pi radians, but we can simplify that to 1/2 radians, and so on and so forth. So these are common angles that you should be familiar with, especially this first quadrant here. Okay, the other ones you could figure out by adding and subtracting, or you could convert directly, but you especially want to know the first quadrant for sure. Okay, there's another concept, something called finding what's called a coterminal angle, and that means basically 2 angles that have the same terminal side. So let me explain how to do that. So finding coterminal angles, and again I'll say coterminal angles are 2 angles that have the same terminal side. So 2 angles that have the same terminal side. So for instance, let's say I measure this angle right here. I'll do it in blue again. So again, this is my initial side. Let's say this is my terminal side, right? So I could just measure this, directly right there. Let's say it's 30 degrees. But another way is I could actually go around once first and then go up to that terminal side. So that would be a coterminal angle. And what would the angle be? Well, in that case, it would be 360 plus 30, right? So that would be 390 degrees. So we would say that 30 degrees and 390 degrees are coterminal. Okay. Also, you could even go, let me do it in a different color. I could measure the angle this way, right? I could go like that. And what is that angle? Well, it must be, I guess, first of all, it's going to be negative, and it looks like it's going to be negative 330, right? So we could also say in this case, so this is negative 330 degrees. We could also say, and negative 330 degrees. All three of those are coterminal, right? Because they represent the same particular angle. So that's all it means to be coterminal, right? We'll do a few more problems later and where we have to solve, we have to figure out some angles that are coterminal to other angles. Okay, one more idea is something called a reference angle. So what a reference angle is, and this is going to be very important when we start talking more about trigonometry and like right triangle trigonometry and trigonometry of any angle in any quadrant. This is going to be very important. So a reference angle. An angle's reference angle is the angle the terminal side makes with the horizontal axis. So is the angle the terminal side makes with the horizontal axis. Okay, so here, let me draw some pictures here. So let's say if we're in the first quadrant, right? Let's say this is our angle here. So in the first quadrant, this would be the reference angle. So the typical angle, normally what we measure as our angle would be the reference angle as well, because that's the angle that think of it as a vector makes with the x-axis. If we're in the second quadrant, so let's say we have an angle now in the second quadrant like this, then this angle right here is going to be the reference angle, because again, it's the angle that terminal side makes with the x-axis, right? In this case, it's a negative x-axis, but that's fine, right? It's whatever it makes with the horizontal axis. It could be positive or negative. If I'm in the third quadrant, so let's say I'm in this quadrant now, then this would be the reference angle. And then finally, if I'm in the fourth quadrant, let's say down something like this, then this would be the reference angle, right? It's always the angle that terminal side makes with the horizontal axis, either positive x or negative x axis. Okay, very important concept. We will use this a lot when we talk about trig functions of any angle. Okay, let's do a couple of quick problems, and then there's one more equation I want to give you for something called the area of a sector, and then that'll be it for this section. All right, so a couple more problems here. Let's say we want to find the angle between 0 degrees and 360 degrees that is coterminal with a standard position angle measuring 2114 degrees. Okay, so how do I do this? Right? How do we do this? Well, 2114 means we went around multiple times, right? Because remember, once around counterclockwise is 360 degrees, another time would be 720, and so on. So we went around multiple times. So one way you could do this is you could simply divide that number by 360. So here's one possible solution. Divide this by 360, right? And you're going to get like 5, I'll say approximately equals to 5.87 something, okay? So we know it goes around at least 5 times and then a large portion of another time. So since I know it went around completely 5 times, to figure out what's left, I could solve it like this, right? I could say I have 2114 minus 5 times 360. Right? Because that means that would be the angle that if it went around exactly 5 times 360. So I need to subtract that from 2114. So if you do that, this is what, let's say, I guess it's 1800. If you do that, you're going to get 314 degrees. And that is a coterminal angle, right? Because remember, we want an angle that was between 0 and 360. So 314 would be the answer. Another way you could do this, I guess, is you could just look at the remainder, right? If you were to divide this out by hand, so 360. So let's see, how many times it goes in? Well, we know it goes in 5 times. So this would be 0, 0, 3. This is going to be 18. And then if we look at the remainder, 4, 1, 3, we know that that remainder must be the coterminal angle, right? 314 degrees. So you could do it either way. You could divide it and just get a decimal like in your calculator. Then you could subtract, and you know it's got to be that the whole number piece times 360. Subtract that value from your angle, and that will give you the remaining angle, right? So that's the coterminal angle. Or you could divide it and look at the remainder, and that will also give you the same answer. Okay, in general, so let's say we're asked to write an expression describing all the angles coterminal with theta degrees. So all the angles coterminal with, I'll do 2 problems. I'll do with theta degrees and then with theta radians. Okay, so how do I do this, right? I want to write an expression describing all the angles that are coterminal with theta degrees and theta radians. Well, I know that it's coterminal, right? If it has the same terminal side, that means that if you go around multiple times, like if you go around multiples of 360, then it's got to be coterminal, right? So if I want an angle that's coterminal with theta degrees, if I want all the angles, then it's got to be theta plus 360 times some constant k, where k is just an integer. So k is an integer. And that will give me all of them, right? By integer, I mean it could be 0, 1, 2, 3, all the way to infinity, or it could be -1, -2, -3 to negative infinity. Right? So that's the set of all those values are all the integers. So for instance, if I did like, theta plus 360 times 2, then that would certainly be an angle that's coterminal with theta, right? Because it'd be an angle that basically you go around 2 more times. Or you could say theta plus 360 times -1, right? That would be an angle where you start at theta and you go clockwise 1 time. And again, you have the same terminal side, so it's coterminal. Okay, so theta plus 360 times k, that will give you all the angles that are coterminal with theta, degrees. Now, how do I do it for radians? Same thing, except instead of adding 360 times k, it would be theta plus 2 pi times k, where again, k is going to be any integer. Right? And that'll give me all the angles that are coterminal with theta radians. Okay, one last concept. This is the area of a sector. So finding the area of a sector. Okay, so let me draw out what a sector is first. So we have our circle again. It's hard to draw this on an iPad, but let's say that's our initial side, this is our terminal side. So the sector, right, this is the angle theta. The sector would be everything in this area here. I'll do it in green. So how do we find that area? Well, it turns out, right, first of all, if I want the area of the entire circle, we know how to find that, right? The area of an entire circle is going to be pi r squared. This is just like a fraction, right, of the area of an entire circle. It's like a piece of the pie. So how do I figure that out? Well, it turns out it's going to be theta, this is in radians, divided by 2 pi. This is like, so what that's giving me is like a fraction of the total angle. So this is like a fraction of, I'll write it this way. It's a fraction of 1 revolution, right? So theta, because 2 pi would be 1 revolution. So I'll write it as a fraction of 1 revolution times, and what do I want to multiply by? Well, I want to multiply the area of an entire circle, right? Because it's a fraction of the area of an entire circle, and that would be pi r squared, right? Remember, that's the area. This is the total area of a circle. Okay, so area of a sector is equal to theta over 2 pi times pi r squared. And of course we can simplify this. I'll call it S for sector. Well, the pi's cancel, right? So this is going to be 1/2 theta r squared. So that would be the formula that you use for the area of a sector. Right? It's simply a portion of the entire area of a circle. Right? It's it's just a piece of that pie. So here's an example where that comes up. Let's say you're told a lawn sprinkler sprays a distance of 30 feet while rotating 45 degrees. what is the area of the sector of grass that the sprinkler waters? So what is the area of the sector of grass the sprinkler waters? Okay, so you could just do this in degrees, right? We could also say that initial ratio is theta divided by 360 if our angle is in degrees. But I'm going to keep it in radians. So the first thing we need to do is convert to 45 degrees into radians. That's good practice anyways. So remember, 45 degrees. If I want to convert that to radians, I have to multiply by pi radians over 180 degrees. Then we can simplify this, right? 45 goes into 45 once. It goes into 180 4 times. So this is the same as pi over 4 radians. And now I can plug into the formula for the area of the sector. It's going to be 1/2 times theta, well that's pi over 4, times r squared, and in this case r was what, 30, right, squared. So this will be basically pi over 8 times 900, and then you can work that out. It's around 353, and it's an area, so it'll be feet squared, right? It's whatever the radius is, whatever the area, or whatever the unit is for the radius, it's going to be that squared. So in this case, feet squared. So that's how much area would be covered by the lawn sprinkler. Okay, great. So that was just sort of to get us started with trigonometry, remind you on angles, the difference between degrees and radians. All right, so we will need all of this when we start really looking at the trigonometry. So actually in the next chapter, we'll kind of ease ourselves into trigonometry, and in particular, we'll talk about right triangle trigonometry. All right, great. Thank you.